All right, everybody. So you've had a chance now to work through the first actual math section of the form and submitted your answer there and moved on to the second part of the form and are watching the second video here. And so what we're going to do is we're going to go over the first question here that you answered, and then we're going to move on to the next part of the lesson. So the first thing that you looked at was, how do we apply the Pythagorean theorem to a question like this? Well, if you take a look here, you've got an x, a 10, and a 16, so three sides, okay? And we have a squared plus b squared equals c squared. There's the Pythagorean theorem, right? A and b are legs, c is the hypotenuse. So remember, the hypotenuse is always going to be across from the right angle. So it's that 16. Also remember, the hypotenuse does not touch the right angle. It's not one of the rays of the right that forms the right angle. So we're going to put our 16 in for our hypotenuse. Then the two remaining sides are our legs. And remember, they do form the right angle. We've got one that's length 10, so we'll make at A, could be B, it doesn't matter which leg is which. So 10 squared, and then we've got x being our other leg. So x squared. Okay, so that was what you were asked for on the last one. Some of you hopefully kind of went ahead and solved this for x, which is what we're going to do right now. So let's take a look here. We simplified. 10 squared is 100 plus x squared equals 16 squared. Just use a calculator, is 256. So we're going to try to get x by itself. So first, let's get x squared by itself. So we can subtract 100 from each side, properties of equality. Subtract the same thing from both sides. The equation remains equal. So now, we're not looking for x squared, are we? We're not looking for the area of a square with side length x. That's a nice visual that we can use to prove the Pythagorean theorem, but that's not what we're looking for. We're looking for the actual side length. So we don't want x squared, we want x. So we want to take the square root, right? And it ends up, again, if we do the same thing to both sides, properties of equality, then the equation remains equal. So we'll have x equals the square root of 156. Now we might take a look at that and say, boom, there's our answer, we're good to go. Or we might be tempted to go to a calculator and get a decimal for that. But that's not what the question's asking for. So the question is asking for you to express your answer in simplest radical form, which means that we've got to take as much out of that radical, as many whole numbers out of the radical as we can, which means we need to divide out as many perfect squares as we can. So remember, perfect squares are things like square root of 4, which is equal to 2. Remember, they come out as whole numbers. So square root of 9 equals 3. Square root of 16 equals 4. Square root of 25 equals 5. Square root of 36 equals 6. Square root of 49 equals 7, etc., etc. Okay? So when you start dividing these in, just get a calculator. Say 156 divided by 49, and you're going to get a decimal. Same thing with 36, same thing with 25, same thing with 16, same thing with 9. It ends up that 4 is the only one that divides nice and evenly in. When you divide by 4, you get 39. Okay, you don't get 39.678 or anything like that. You get 39. So it means that you can nicely factor square root of 56 into the square root of 4 times the square root of 39. Okay, and you can even look at 39 and say, well, that divides into 3 and 13, both are prime numbers, so you can't divide 39 into any perfect squares. So we just take the square root of 4, make that 2, and we have the square root of 39. And that is our most simplified radical form. Sometimes you can take out a lot more than just the 2. This time that was it. So, all right, so let's go ahead now and take a look at the converse of the Pythagorean theorem. All right, so converse, right? Now we're starting to think more like a typical geometry class, right? Throwing in these verbal terms, you know. It's not just a nice formula anymore. It's a theorem, and the theorem now has a true converse because we got ourselves a yellow box, right? Which means that mathematicians said this here is true 100% of the time. So the theorem said that, hey, if we have a right triangle, then a squared plus b squared equals c squared, right? Well, now we know that we can go the other way with this. We can actually say, hey, if a squared plus b squared equals c squared, in other words, we look and we say, this could be 2 legs and a hypotenuse. If we take the 2 legs and we square each of them, we add it up, and we equals the square of the hypotenuse, then the triangle is a right angle. Okay, so now we have 2 100% true statements. Okay, we have a converse. This is going to be a little bit new. You haven't used the Pythagorean theorem as a tool for reasoning like this before, and now you're going to get a chance to. So let's go right in and look at an example and a problem for you. All right, so let's take a look here at a problem. So a triangle has side lengths of 12.5, 30, and 32.5. Is it a right triangle? Explain. So I'm going to ask you to do this, okay, before we even do an example. Sometimes the assessments just see, can you understand this by thinking it through and kind of figuring it out. So first thing you're going to need to do is decide which one of those lengths is the hypotenuse if you're going to test a squared plus b squared plus c squared. Because remember, the converse of the Pythagorean theorem says that if you take the 2 legs, square them, add them together, it should be equal to the square of that third side, which would be the hypotenuse. Okay, so you've got to decide though which one reasonably is the hypotenuse, and there's a way to know based on something that we've done in previous classes and previous chapters, and then test it out and let me know. So go ahead and do that with the question here, and then in the next section of the Google form, we will have our last little video where we'll go over this and look at some triangle inequalities with the Pythagorean theorem. All right.